present to you about the environmental impacts of cabling, especially in offshore industry, compared to what we have so far seen in the literature. So I believe I am here with my two colleagues, and excuse me, I believe we're having some technical difficulties. Okay, so I thank you for your patience. My name is Nikola Krilovic, and I am an environmental scientist and a consultant focusing on different problems within our environment, and one of my passion projects is also offshore wind. So a little bit about myself. I have been involved in national and EU environmental projects, mostly in the Mediterranean region, as well as in river basin management. I have consulted for private and public entities from the side of my employers and also personally. And I have been involved with the University of Malta and the University of Vienna from an academic perspective, as well as privately as part of my own company, as well as with 3B infrastructure asset management, all skills that have led me to offshore wind and asset management in general. So today I'm also joined by Henrik Bang-Andreas and Ole Henrik Bang-Andreas, who are the moderators. And as such, I hope that you will enjoy what I want to present to you with regards to environmental impact of offshore wind cabling systems. So if you have any environmental questions, please just write in the chat box, and always you can write to me on my email that's listed here, which is the company email, and I'm very happy to answer it because aside from being work, this is also a very big hobby and a passion of mine. So in order to summarize the last webinar on November 17th, 83% of all offshore wind insurance claims are subsea cable related. So it tends on to be a big issue. And it usually stems from cable and CPS, which is cable protection system fatigue, and failure simply not being the focal point. So it does not really affect only the insurers, it doesn't affect other monetary things as well. It does also have some intrinsic value that we want to focus on, and that is the environment. So before we go into it, why is this actually important? Why are all of us here today, and what is it with with renewable energies? So there are many different focal points why renewable energies are important, and the energy sector is emitted globally 36.8 gigatons of CO2 in 2022. That small dip that we had was simply due to COVID, but now we're back on track to increasing the demand, and therefore mitigation is something we desperately need, and all unnecessary emissions should be avoided. So there are many methods that we're really trying to find here, but all of them have a plus and a minus. So we can also have trade-off. For instance, when you manufacture something that's actually renewable, you emit a lot of CO2 in the meantime. You also have impact on the wildlife while you're constructing something or building something. And there's also the social impact, a very important but often overlooked issue. And then there are the offshore wind farms. They are one of the many renewable energy solutions available to us that make it desirable. And why is it? Why is it that this is something that we're really interested in, first of all, as a company, but also something that you see on the news or in general? So definitely wind conditions drive higher energy yields. They're a lot bigger out there. And simply there's a greater amount of space. So you really don't have to worry about any unnecessary burdens helping you build your offshore wind farm. And there's also this personal intrinsic value of the NIMBY effect, so not in my backyard, which simply refers to the infrastructure being distanced away from the communities, which on the other hand helps us to not see this and not find this as nuisance, but then again get all the benefits of the renewable energy. And there's also, of course, reduced audio and visual disturbances, which directly relate to NIMBY, but those are so far haven't been better than in offshore wind cases. And then again, in general, global offshore wind is growing. As you can see here, we have really constant growth in the demand of new installations going worldwide. Of course, Europe is leading in this regard, but simply by 2030, we'll see it more than double in terms of growth that we're expecting. This is actually based on scientific literature, and you should know that most of the things on this webinar are either peer-reviewed or checked by competent authorities. And then there is another issue. As I've told you before, not everything that's green is necessarily 100% green. There are always some issues and some trade-offs that we really need to take into account. And renewable energy, such as offshore wind farm, is also not an exception. So there are some trade-offs and unplanned environmental impacts that you really need to take into account. And if you don't, the whole concept of it being sustainable and being this pinnacle of green energy might simply be defeated. So there are actually many environmental consultancies all over the world being hired by government agencies and other concerned groups that want to do a proper EIA, which is an environmental impact assessment, and they actually found some noticeable results. And as you can see from this chart here, there are different spheres during the operation of the wind farm that actually can contribute to an environmental impact. But something that's actually missing here is cabling, and not really just cabling, but cable repair. So you can have different impacts, definitely, and you can expect that some things are going to occur, but there is a big picture missing that people don't realize. So taking this from Taormina et al., a review paper regarding all the environmental impacts of cabling, they have found that there are 4 different phases where you can see any kind of environmental impact. Dynamic, which can be during operation, laid down as well when it's already there in the ground and when it's buried, and during installation and decommissioning. All of these result in different types of environmental impacts. Naturally, not going into too much detail and focusing on the cable protection and cable replacement, we can later go on and tell you why are we here and what is actually happening. So there is a sustainability perspective from this. Offshore wind cabling impacts have been researched by academics and private entities alike, and I'd like to point out it has been offshore cabling as a general thing. But what about replacement? So what happens is once a cable ultimately fails, its replacement involves a complicated supply chain with many different stakeholders. And it's actually a specialized operation requiring detection efforts and estimation of damage magnitude, meaning you need to have a lot of engineers and other repair people who are really specialized on their fields and also probably costly. And you need to dispatch a specialized vessel called a cable laying vessel, or short CLV, to the repair site that's actually loaded with these cables. And as such, this can negatively affect the environment. We need to look at this as more of a true concern rather than something that we can just dispose of as a risk. Therefore, the presentation today. So what is going to happen in our webinar? We're going to focus on the marine ecological aspects, the emissions and social costs, and the resources management aspect of repairing offshore wind cables. So these are the 3 main standpoints that I wish to present to you in order to learn how big of an issue this can actually be if it's not taken into account. So we can actually start with the marine ecological impact. Before we begin, eco in general refers to everything green if we're looking at popular science or if we're looking at marketing campaigns, but in this regard, it refers to the flora and fauna, so the wildlife that we actually find in this area. So there is physical disturbance that actually happens during cable damage, replacement, or removal, which causes the risk to the survival of marine flora and fauna directly and indirectly. So what would directly be? If you disturb, displace, or remove cables, you can physically damage the ecosystem and negatively impact the life underwater. It's simple, but it still needs to be said. So if you're doing something, for instance, a stabilization effort every time, you are doing things that are physically destroying something that's happening at that part of the sediment. But what's more important in this regard and what's actually overlooked is the latent processes. It's the indirect impact. It's something that happens without you even realizing it because it's happening at a later time. And that's something we really need to take into account and something that hasn't been researched. But it definitely happens. So, with our case study, the disturbances related to this case are focused on rock dumping, rock mattress covering, anchoring, or even ducting. And why are these risks? So, you can have direct physical damage to the habitat. That's something very obvious that all of you can probably assume happens when you're dumping things into the water, when you're putting all these big masses, heavy masses, you're bound to destroy something underneath. But what happens when it's already underneath? So, for one thing, the suspended sediments are disturbed. And those are the sediments that you find down there. And when you lift them during the impact of, for instance, a rock, you actually prevent crucial processes for organisms such as light absorption and filtration, and you can even cause oxygen depletion. And usually people would argue that these things are very short term and that there would not be any significant impact on the environment. But if you expose it to bedrock, chalk, or gravel, fauna could be prone to long-term damage, which is over 6 months because of the very easy process of being disturbed. And then there's also the reef effect. Although it may sound like an attractive thing, attraction of non-local fauna or something you might know as invasive species is not good. So you should imagine an ecosystem as a big bubble that has specific little bubbles inside it that all fill out their role. If you disturb it by introducing an invasive species, then you can start a domino effect, which can be caused by disturbing the ecosystem and by displacing them and their food chain. And additionally, something that actually happens a lot and usually people take it for granted is the noise pollution and chemical pollution that might occur. So that means that if we're looking at what has been done in the literature so far, the environmental impacts that we can relate to the cable repair and replacement mostly correspond to what happens at the installation and decommissioning processes found in the paper by Taormina et al. So you have everything here listed from reef effect through different pollutions such as chemical and noise pollution, and you also have the suspended sediment disturbance that is something that can really have a big effect. But then again, that is not everything. Even if you manage to somehow lighten this stress, you have another thing that is happening in the environment because it's a big spectrum actually, and that is emissions. So we have all probably heard of COP28 happening recently, and we have heard all these talks about replacing everything with renewable energy as much as we can and as fast as we can. But what happens during the operation of our renewable energy systems? So we need to find what is happening during the cable replacement process that can negatively impact the environment from different angles, and emissions is one such case where we have a cable laying vessel and we operate it on an exhaustive amount of fuel, so it's a behemoth of a vessel and has a long operational time frame. And if you multiply this by a number of incidents that might occur throughout the year, you can actually get a substantial number that should not be ignored. So for instance, based on public available data, a best, normal, and worst case scenarios in terms of annual emissions were calculated. But as with any model, we had to make assumptions. Based on the data from 4C database that's actually supported by researchers that took the same database, we rounded it to 17 breakages per year in the context of Europe. And then fuel consumption was also calculated specifically for cable laying vessels as being 0.45 tons per hour of fuel. And then CO2 emission factor for CLVs is 3,190 kilograms or 3.19 tons of CO2 per metric ton. And given that there is, of course, always uncertainty and standard deviation between how many breakages can occur within a year, it's really unrealistic to simply say that one single number occurs. Therefore, we also included not only a 10% uncertainty, but we also included two scenarios. One is called a close by scenario, which has 50 hours spent of traveling of the CLV to and from the area and 200 hours on site. And then there's the cross-continental one, where you borrow or you operate a vessel from another part of the world that comes and does the reparation of the cable for you. And with that being said, our models currently indicate the following things, and that is that, for instance, if we take the actual average, we have around 5,500 tons of emissions per year from an average of 17 failures per year if we use the close by case study, whereas if we use the far away case study, it's around 11,500. The number becomes much more drastic if we go to 27 incidences cable failures per year, which is 10 instances more, and then we have the 10 instances less, based on the standard deviation of all the cable failures that happened. And to put it to different numbers, this actually relates to also 5.5 thousand UK households if we have a close by operation, and 11,000 households if we have a cross-continental operation, if we assume 1.1 ton per inhabitant of CO2 in the UK, which is the latest figure. And as such, this is something that is simply what we refer to as a trade-off that should not happen. So if we are assuming all our systems function properly, and if we want to produce green energy, we are having a hole in our boat, meaning that we are emitting CO2 where there's actually something that is simply wrong. So it's not a necessary ends justify the means type of scenario. It's something that occurs and that's rather unpredictable and should be reduced. Otherwise, it actually emits as much CO2 as a small community in a very well-developed Western European country. From an emissions perspective, something definitely should be done, and we are hoping it will be. And what's really important from the emission side as well as the social costs. So they're a big part of any ESG practitioner's concern, because we're focused not only on the environment, but also on the social part and the governance part. And therefore, offshore wind market, given that it's a really booming market and it's renewables, it's not an exception to this rule. And what is the biggest thing that we have found? It's actually that the takeaway point is that public perception of offshore wind farms depends on prior encounters of such projects, which means any negative experiences in terms of costs, aesthetics, wildlife, or tourism can be detrimental to the public perception, and it would really be a pity because it is an optimal source of green energy, and unnecessary flaws such as what we have seen just now should be avoided. So basically what I have here is the quote from the research paper that it confirms the hypothesis that experience of offshore wind farms has a significant effect on attitudes towards them. It was a study done in Ireland on the perception of offshore wind farms, and if you're interested in the source, I really recommend, because it makes a really good read. And I just want to show here that social costs are not something that we have just come up as a aspect of our own. It's something that's actually been researched, not from a cable perspective, but in general from offshore wind commissioning and decommissioning. For instance, here we have the Horns Rev total social cost breakdown, and as you can see, there are many different parts of the asset management process that play a role on the social costs, meaning that there should be no extra burden that's not needed when we're doing cable repair as well. And then there's also resources management, which is more of a monetary and environmental issue. And most components of decommissioned cables are recyclable when decommissioned. That's clear. So we have copper mostly, and we need to take into account that repaired cables have not been observed through this lens due to their unplanned nature. So it's something that's more what I'm proposing we should explore more. because theoretically almost every part of the inner working of the cable is recyclable, but the polymer insulation such as EPR and the XPLE, regardless of if they're used in offshore wind or not, it should be noted that there are no economic benefits to disposing them. It's just dictated by basic waste management and therefore most likely directed to landfills or incinerated. And therefore, it's a good food for thought for anyone watching today that it's something that should be researched. And with that, I would like to give you my outlook and my conclusion. Basically, the general consensus from what we have found in literature and in our research is that prevention is always the preferred alternative to adaptation, meaning that we need to find ways to prevent unnecessary breakages instead of trying to find ways around it or disregarding it as simply a working risk that we have to deal with. We also need to know that COP28 signals the beginning of the end of the fossil fuel era, and as such, all the professionals involved in the offshore wind are going to be under high scrutiny on their whole chain of command and their whole operation, meaning that there should be avoidance of unnecessary emissions or effects on the environment. So there is a potential increase of cable breakage because we're building more and more offshore wind. And if we keep using the same method, we're going to keep increasing these potentials and therefore put an unnecessary strain on the environment. So our opinion is that effort should be put on mitigating unaccounted environmental impacts, including cable repair as discussed today, because less breakage means simply less cable repairs. There is not a magic bullet to this. We simply need to reduce things in order to see less of an environmental footprint and simply reduce the physical impacts and therefore lower emissions and properly manage the resources. And in general, the most logical thing based on it is that if we have less breakage in the turbine operation, we will be providing more green energy and therefore we will be offsetting the non-sustainable sources quicker. Whereas if we have an issue with our green energy, we will have to rely back on sources that we're trying to get away from. So with that being said, I would really like to thank you for your time, and I hope you have enjoyed this presentation. So now is the time for Q&A, and I am open to any questions you might have. So if there are no questions, I will take that as a compliment because it has actually been very explanatory to you. I wish you the happiest of holidays, and as always, please reach out to Ole or Henrik or myself. This will be pre-recorded. You have us all on LinkedIn, and simply follow us to stay updated. Thank you very much.